Hi cuties, we're back with Quadrivium. I may say it wrong. Quadrivium. I don't know, I feel like I've been like, I'm reading this book and I may have been saying it wrong. I don't know. Perhaps not. Perhaps I'm quite brilliant and I would never make a mistake like that. In fact, I pronounce all words correctly and accurately, always. When I record, I've been having to unplug the refrigerator because it hums. But I didn't, so hopefully it doesn't bother you. Okay? Okay. Qualities of quanta, that is Quadrivium. The qualities of quanta, and that's where we went through the factors, ratios, triangular, square, and cubic numbers, prime and perfect numbers, and the way that they appear in sequences like Fibonacci and Lucas's sequence. So that's where we left off, and then we were seeing the solids. These are the solids, and then these are what they call the grids. Ooh. Do we have any idea where this is gonna go? What's next? The gnomons, ways of growing, GNOMONS. Aristotle observed that some things suffer no change other than magnitude when they grow. Originally a term for, I skipped a sentence. He was describing the principle of the Greeks referred to as mnemonic growth. That's in quotes. Originally a term for a carpenter's tool, a gnomon is defined as any figure which, when added to another figure, leaves the resultant figure similar to the original. Contemplation of the gnomon leads to an understanding of one of nature's most common principles, growth by acceleration, growth by accretion, ACCRETITON, accretion. Structures such as bones, teeth, horns, and shells are developed in this way. The ancients had a general fascination with patterns and progressions created by whole number ratios. Examples are triangular, rectangular, square, and cubic numbers. Opposite top, NC 2 pages 358 and 367. Also, Plato's lambda or lambdoma, which produce the full range of musical ratios. The proportional rectangles used in Greek design, where each subsequent rectangle is built on the diagonal of the previous one, opposite center. The Fibonacci sequence is a more recent discovery, but relies on the same principle of mnemonic growth. The drawing below shows a cutaway across a section of the Aztec temple of Tenayuca, revealing 5 nomadic reconstructions made every 52 years when their calendar, inherited from the Mayans, was reset and all buildings renewed. So we've got the opposite top. Examples are triangular, rectangular, square, and cubic numbers. Opposite top. Okay, triangular numbers. Here the sequence 1, 3, 6, 10. Rectangular numbers. Here the sequence 2, 6, 12, 20. Rectangular numbers, here the sequence 2, 6, 12, 20, increases in a musical fashion. Musical, a rectangle. Interesting. Square and cubic numbers, here the square faces 1, 4, 9, 16, and the cubes 1, 8, 27, and 64. So the triangulars, these numbers here, the triangulars, these numbers here, the musical, these numbers here, the faces, square faces. 1, 3, 6, 10 is triangular. 4, 5, 6, 7, 8, 9, 10. 1, 3, 6 equals 10. It's out 6, 7, 8, 9, 10. Okay. 12, 2, 6, and 12. Here, 20. 6, 7, 8, 9, 12. Okay, that adds to 20. 9, 4, and 1, 16. 27, 8, and 1. Is that 64? No, that's not 64. It's a little low. 9, 10, 11, 12, 13, 14. No, 9, 4, and 1 isn't 16 either. Interesting. But it's square and cubic, so it's like times 2 maybe. Okay. Interesting. And then Plato's lambdoma, the heavier lines show the octave 2, 1, while down on the other side, number triple. While down the other side, numbers triple. Also present are the 5th, the 3, 2, and the 4th, the 4, 3, and the whole tone, 9, 8. Okay. And now all these numbers are part of this. No, 64 is not. 8, 27. Okay. 16. So far, 16 and 64 aren't part of it. Neither is 20. But 27 is. Proportional rectangles. Starting with the square, side 1. Each successive rectangle is built on the diagonal of the previous one. Create squares of area 2, 3, 4, and 5. I've seen the golden spiral before. Starting with a square, we build new squares to create a spiral of squares. Starting with a square, we build new squares to create a spiral of squares, which grows and grows by the magic Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. I have a friend who has a reel on the Fibonacci sequence. We'll have to phone Boise. The number of growth. The Fibonacci sequence appears in many living things. Here we see it in the number of leaves and branches in a simple meadow daisy. One, 1, 3, 5. Can't say I understand any of that, the numbers of growth. I can't say I know what that, but it's very pretty. Can't say I understand what much of these pictures mean. But I'm looking forward to when it drops in, and I do understand very much what they mean. And numbers, I've got that math story, and I wasn't good at math. I took algebra. I took it. I remember taking it. I had that. A female teacher at Bucks County Community College. Then I took it. I took night school we had a vocational school, tech school. And I took it there, night school, with two of my other guy friends, Papa Witch and Aaron Goodman. And I would say I remember like trying to do math and it just being like hitting a wall. I was like, I don't understand. And they were like, you overthink it. And I was like, what does that mean? And then I remember even being younger. So that was like, we were driving, so 16, 17. When we were younger, I took it at Bucks County Community College. It wasn't until my first year of college that I was taking algebra, and I failed it there. So then I had to go to night school at the tech school. And when I was even younger, we would play this game in class, maybe 2nd grade, 3rd grade, 4th grade, called Around the World. And the teacher gives you flashcards of whatever, addition, subtraction, multiplication, division, whatever grade I was in. And I just didn't get it. It wouldn't, even when I'm thinking, even when I like put myself in that little me's head, I'm just like, seize and fry and fall over. I didn't actually do that. I would just stand up and be like, and they would say 26, and I would be like, I just didn't. And then instead of like getting me to understand, I don't know if I had a block against understanding it or what, but it's like they just told me it was gonna be hard. It's just gonna be hard. It's just gonna be hard. Well, why can't someone help me so it's not so hard? Like, why can't someone actually teach me how numbers work? Very interesting. Very interesting. Back to the book, shall we? Time and space, cosmology, and manifest number. Looking around us, there are numbers that particularly manifest in the heavens around Earth. These are covered in detail in Book 5, but we will introduce a few here. There are, for instance, 12 full moons in a solar year, but the 12th falls 11 days short of the end, which means that the 12 moon year, like the Islamic calendar, slides slowly against the solar year, coming around again after 33 years. 3/11ths. 3/11ths. Other sun-moon marriage numbers are 18 and 19, as eclipses repeat after 18 years, and full moon dates repeat after 19 years. Stonehenge displays this as 19 stones in its inner horseshoe. 2 full moons occur every 59 days, and Stonehenge records this in its outer circle of 30 stones, which is half width, suggesting 29.5 days per moon. Venus draw 25 per moon, you little cycle, women's cycles. Venus draws a 5-fold pattern around Earth every 8 years, allowing us to draw an amazing diagram opposite center. In those 8 years, there are almost exactly 99 full moons, 9 11s, and the number of names or reflections of Allah in Islam. Jupiter draws a beautiful 11-fold pattern around Earth, opposite top. Jupiter. Here, I have a blanket with the Mayan calendar on it. So, opposite center. Venus folds a 5 pattern around Earth every 8 years, allowing us to draw an amazing diagram. Opposite center. In those 8 years, there are almost 99 full moons, 9 11s, the number of names or of reflections of Allah in Islam. Jupiter draws a beautiful 11-fold pattern around Earth, opposite top. An 11-fold. The numbers of many longer cycles, such as the great year or precession of the equinoxes, are also rich in secret qualities. Each great month, such as the age of Pisces or Aquarius, lasts 2,160 years. Also, the diameter of the moon in miles. 12 great months give the ancient Western value of 25,920 years for the whole cycle. The ancient Maya were superb stargazers. Their calendar synchronized not just the sun and moon, but also Venus and Mars. They worked out that 81, or 3 by 3 by 3 by 3, full moons occur exactly every 2,392, or 8 by 13 by 23 days, with astonishingly accurate gearing. So that's the Mayan. They worked out that 81 full moons occur. Pretty amazing. This stuff is deep. I mean, it just looks like the numbers are like the circumferences and patterns. Very interesting. Okay. Babylon, Sumer, and Egypt. Early number systems. Around 3000 BC, the Sumerians developed the earliest writing we know of, and with it, a base 60 number system. See page 356. A particularly useful number, 60, is divisible by 1, 2, 3, 4, 5, and 6. Working in the base 60 gives number patterns with different from our modern base 10 system. A Sumerian clay tablet impressed with a cuneiform, cuneiform, wedged shape stylus shows the 36 times table opposite their base 60 system. Survives today as our measurement of cycles and circles with 60 seconds in a minute, 60 minutes in an hour, or degree, and 6 by 60 equals 360 degrees in a circle. 6 by 60, 360 degrees in a circle. 36 times opposite. Ancient Egyptian numerals were made of characters standing for 1, 10, 100, and so on. The example of Egyptian arithmetic is their method of multiplication, which uses repeated doubling followed by selective additional to the final answer. Addition to find the answer. An example of Egyptian arithmetic is their method of multiplication, which uses repeated doubling followed by selective addition to find the answer. The ancient vision of number is a musical one in which every number inverts in the mirror of unity, 2 becoming a half, 3 becoming a third, and so on. In base 60, this reciprocation is especially beautiful as all multiples of 2, 3, 4, 5, and 6 become simple fractions. For example, 15 becomes a quarter. The Babylonians inherited and used this system to invoke their gods. Egyptian fraction. Can we say more? The Babylonians used this system to invoke their gods. Egyptian fractions used a mouth hieroglyph below, while fractions of volume were represented using the eye of Horus. 36 times table, Egyptian multiplication. Numbers of the gods. Symbols, arrow, Anu, Enlil, Ai, Sin, Shamash, Ishtar, Negral, Marduk. The eye of Horus. A quarter plus an eighth equals 3/8. Math. What's really beautiful is I'm actually understanding these fractions. I remember being pretty okay at fractions. That's interesting. I think I was okay with fractions. Algebra? Nah. Okay. Ancient Asia. What are we doing here? The contacts are getting a little sticky. Ancient Asia. Manipulating intents. You ready? In China, a written decimal system with 13 basic characters has been used for more than 3,000 years. Another particularly beautiful system of writing numbers is the Swanzi or Sangi rod notation. complete with a small zero used in China, Japan, and Korea in some form since at least 200 BC. Below. Later, the famous Chinese abacus replaced by rod numeral counting boards. The speed of its operators, particularly in the Far East, is legendary, and it is still a widespread use today. I've seen that. It's fast. I've seen them. India has an ancient numerical tradition. Number is prominent in many of its scriptures, and Indian cosmology used huge numbers rivaled today only by those of modern physics. Indian numerals originate with the Brahmi system of numerals with 45 characters. For the number 1 to go to 90,000 in time, the speculations of Indian mathematics required a new system, combining the first 9 number names with power of tens, rapid and elegant calculation techniques, and the description of a very large numbers resulted in some astonishing calculations. The 0 also emerged to denote an empty decimal power without confusion. See page 56. Indeed, it is from India that we received, via the Arabs, our modern decimal place value system. We got the decimals from the Arabs. Page 56. Oh, whoa, whoa. The Greek Salamis tablet, Roman calculus, the Roman hand abacus, Middle Age counting board, Middle Age line board, Chinese swapan, Japanese soroban, and the Russian seat. The number 9,360 on various counting boards. Oh, interesting. So the number on each of these different style of boards says 90,360. Show me how. Somebody tell me how. In what ways? Next, 58. Gematria. Talking numbers and secret codes. The Phoenicians used a very neat 22-letter consonant alphabet to encode the sounds of their tongue. In time, this script was adopted by most Mediterranean people, and through its Latin variation came to be the alphabet that we use today. Gematria uses letters and as numbers. Gematria uses letters as number symbols, so language becomes mathematics. Important canonical, geometrical, musical, metrological, and cosmological numbers are defined by many key terms in ancient texts, first appearing widely in ancient Greece. Gematria was subsequently adapted to Hebrew and also Arabic, where it is known as abjad. A simplified system also exists in all 3 languages, using the same values without the zeros. The example below shows 2 related phrases connected through an identical sum. itself the lunar radius in miles. It gives some idea of the magical and the simultaneous resonance between words and numbers that any literate and numerate reader would have experienced, since for more than 1,000 years, gematria was not merely an occult specialty, but the standard way of representing numbers. The secret science is still used today by mystics and sorcerers who use its connections between words, phrases, numbers for their numinous significance and talismanic power. Wow. Okay. Wow. Alpha, beta, gamma. Beta, gamma, gamma, gamma. Dal, dalet, delta. Theta. Very interesting. Hebrew. Arabic. The Greek system includes the disused letter digamma and quappa in their original order, and reinserts the disused san at the end. Likewise, the Hebrew system uses 5 special end-of-word letter forms to reach 900. In the Arabic system, the letters for 60, 90, 300, 800, 900, and 1000 differ in the West and the East of the Islamic world. Maybe that's why I just didn't get math. I'm just from another part of the world. Okay. Magic squares. I think that's gonna be it. Magic squares, when it all adds up. Magic squares are a fascinating way of arranging numbers, and there are whole books about them and their secret uses. The magic sum of any square is the same whichever line is added. 7 magic squares are traditionally associated with the planets opposite 3 by 3 square in Saturn, and the squares increase by 1 order as they descend through each planetary sphere to reach the lunar 9 by 9 square. Elegant patterns of odd and even numbers occur in these squares, shaded in the diagrams. Each planet also has a magic seal based on the structure of its square, a useful code for wizards. A magic square is an example of permutation, ordering things in a set of particular ways. There are 8 ways to sum to 15 using 3 numbers from 1 to 9, and all 8 ways are present in the 3 by 3 magic square. Other totals found in magic squares are worth a second look. The Maya would surely have delighted in the fact that 8 by 8 squares has the magic sum of 13 by 20, while the solar line of 11T1 gives 666 as the square sum, as 1 plus 2 plus 3 plus 4 plus ... plus 34 plus 35 plus 36 equals 66. With geometria, it is additional magical key words and magic squares naturally interweave in the secret world of spells and other talismanic arts. Words and magic squares. Words and magic squares. Wow. It looks like Sudoku. Pretty cool stuff. All right. That was page 50. Okay, next one. Next time. Pretty amazing. Whoop. Have a really wonderful rest of your night. It's been really fun getting to read to you. And if you don't care, then you'll probably never hear this message. But if you do care, thank you for caring. Thank you for letting me read to you. Brings me much joy.